People think, especially the students, that learning math subject, calculus, or the infinite series is just a waste of time. From its formulas, process, and analyzing the problems connected to it are all pahirap sa buhay lang. But they just don't realize that anything that includes numbers, measurements, or series are part of the happenings in our daily lives, useful and beneficial. Let's define infinite series. Infinite series is the sum of the terms of an infinite sequence a sub n where n is equals to 1 up to infinity that has terms of a numbers of a sub 1, a sub 2, a sub 3, and so on and so forth. The dots or ellipses mean that the number of terms is the infinite. Let's also define geometric series. The geometric series is one of the theorem of the infinite series that will also take part for the real-life application that this video will discuss. So what is geometric series? Geometric series. It is the summation of a series with a non-zero constant where each term is multiplied by a ratio raised to the power of n minus 1 if the nth term of the series starts with 1 or raised to the power of n if the nth term of the series starts with 0. This series is convergent if the ratio is less than 1 and divergent in opposite if the ratio is greater than or equal to 1. And for the exciting part, the perpetuity of finance. Then it's time for the application. The theorem 1 of infinite series, also known as the infinite geometric series, can be used when the sequences of the values of the terms have a constant ratio. We can also use it in our daily lives because this series is related and can be applied in the field of perpetuity. But how does the infinite series and the geometric series is connected to the perpetuity? Perpetuity is a type of security that pays for an indefinite period of time. In finance, perpetuity is defined as an endless series of identical cash flows. Perpetuity is also employed in a number of financial theories, including the dividend discount model, or DDM. In using the geometric series, which is the theorem 1 of the infinite series, we can use it in deriving the formula for the perpetuity. No-growth perpetuity. To derive the formula for the present value of a no-growth perpetuity using the definition of an infinite series, we can start with the following definition of perpetuity. PV is equals to summation of C over 1 plus R raised to 1 when T is equals to 1 up to infinity, where PV is present value, CF is constant cash payment received every period, R is interest rate per yield, T time period, which goes to infinity in the case of perpetuity. In a perpetuity, the cash payment C is received every period indefinitely. Now, let's rewrite the series as an infinite series. This is an infinite geometric series with the first term A equal to CF over 1 plus R raised to 1, and the common ratio R equal to 1 over 1 plus R. In an infinite geometric series, we can calculate the sum of an infinite number of terms using this formula. Constant growth perpetuity. The mathematical derivation of the present value formula below was derived by Abdelkader 2012. The present value of a growing perpetuity P with payment C and interest R is given by. You may recognize this from calculus classes as a geometric progression. X is equals to summation of z raised to t where n is equals to 1 up to infinity, where z is a positive constant that is less than 1 and x is the sum of the geometric progression. The series is important in calculating the present value of the cash flow in the past year. So how does this work in practice? Let's take a look at an example of a growing perpetuity. We have looked at how mathematics and calculus are developing with infinite series taking center stage. In this series, initially perceived by many as abstract and challenging, are in fact essential tools in real-life situations across diverse fields, especially in the perpetuity of finance.